In this video, we'll look at a hypothesis test for population correlation in the Casio graphing calculator. The independent variable x is the number of hours students self-reported working on a class in the first week of an intensive 5-week online BizStat class. And y, the dependent variable, is the week 1 exam score. We'll conduct our test at an alpha of 0.05, and our null and alternative will be rho equals 0, rho not equal 0, where rho is the population correlation coefficient. If we reject the null, we will find a significant correlation between the x and y variables. The first thing we'll do is get our sample correlation coefficient. We'll conduct the test using 2 decision rules, and then we'll reach a conclusion. On the Casio, in the main menu, click on 2 to get into statistics, and then you'll want to enter your data in lists. Now that we have the data entered, we go to F3 for test, F2 for T, and F3 for reg. There's more than one way to get the correlation coefficient for our sample, but this is also the way that will let us conduct our hypothesis test at the same time. In the linear regression t-test window, we have to choose the direction of the test. In this case, we have a null and alternative of equal, not equal. We'll leave it set to the not equal for the alternative sign. My X list was list 1, Y is in list 2, and we'll execute. When we scroll down in order to find the R, sample correlation coefficient, which is 0.4466, now we can identify the results for the first of our 2 decision rules. Reject the null if p-value is less than alpha. P-value is the third item down in the test, p equals 0.267. That is a much larger probability than the significance level. Let's consider the second decision rule. We're going to compare the t-critical value with the t-test statistic that we got in our output. If the t-test from the output is in either of the 2 tails, then we'll reject the null. So we are using the t-distribution here, and we're going to use the inverse t function to find the critical values in the left and right tails. We hit the exit button to get back to distribution. That's F5 for distribution, T for the t-distribution, and then inverse t is under F3. Make sure it's set to variable. Since we have alpha of 0.05, half of that is 0.025. Degrees of freedom is n minus 2. We have 8 items in the sample, 8 students' data represented. N minus 2 is 6, and execute. The Casio expects you to enter area to the right. 2.5% to the right of the upper tail gives me this t of 2.45. Had I wanted the lower tail, I would have entered 97.5% as my area. On a 2-tailed test, the t is plus or minus, so we don't need to run it twice. Now we can compare. Will we reject the null? Is the t-test from our original output of 1.22 larger than the right-tailed t of 2.45? No, it isn't. And we would compare the right-tailed t critical value with the t-test because they are both positive. In both cases, in both decision rules, we have the same outcome as we must. We will fail to reject the null. We did not find sufficient evidence to conclude there is significant correlation between this x and y variable. If you found this helpful, give it a thumbs up.